So let's talk a little bit about earned value management. And this is a way to measure project performance against the baselines. So again, you can see the deviations to the cost or schedule baselines and then project forward. So for instance, I had a hardware guy and he was always a terrible pessimist. And that was good because hardware always came in ahead of schedule and under budget. And so, but after a while, I sort of figured that, and I could put a little grain of salt into his estimates. But the software people were just such optimists. And so I'd always have to clock that back a little and say, okay, well, you say this, but really, are you going to, it's going to take 25% more. And truly, because especially when you have your top software guy doing the estimates, he thinks everybody can do everything as fast as he can. And that's not the case. You've got your B and C and, maybe lower team players. And so you've got to look at what the average person can do. At any rate, here are some of the acronyms and terms. And again, these are probably things you want to think about, including on your brain dump. And again, plan value, because we've already overloaded that acronym. So you've got to understand if you just see PV in a question, whether it means present value or plan value due to context. But this is what the budget is assigned to complete the scheduled work. And then the earned value is the work that has actually been performed. And the AC is the actual cost, which is the actual cost incurred in the work performed. The BAC is the budget at complete, so that's the total budget for the total work. And EAC is the estimate at complete, so this is the expected total cost for the project. The estimate to complete is from the point at which the project sits, what is going to be needed to finish the remaining project work. So that's kind of an interesting number because it might be more than what you have left in the budget. And then the variance at complete obviously explains that problem that we just discussed, and that is the projected budget surplus or deficit at the end of the project. So you will get questions about this. Old-timey terminology, they used to use actual cost of work performed. So rather than AC, they used ACWP. And this was truly over a decade ago. But some people are still seeing that terminology on the test. So, just be aware that, you might see, or like for planned value, it was called BCWS, budgeted cost of work scheduled. So again, just, be able to roll with the terminology. And of course, then that leaves earned value to be the budgeted cost of work performed, so BCWP. So again, you might want to have those on your cheat sheet, so if that term gets thrown at you, that acronym, you can think, okay, this is what it really means. So here's some of the formulas, and again, these are big formulas for your cheat sheet. The cost variance, of course, is the earned value minus the actual cost. And so obviously, if you're negative, you're over budget. If you're positive, you're under budget. So you probably want all these things. You probably can remember what cost variance stands for because we're going to say it about 100 times today. But you want the formula and you want the interpretation.
You keep the slide up.
Huh?
I'll keep the slide up.
Okay. Oh, yeah. And then schedule variance is earned value minus planned value. So obviously negative means you're behind schedule and positive means you're ahead of schedule. And so those are the variances. And then we get into the indices. So the cost performance index is the earned value over the actual cost. So basically, for every dollar you spend, what is your bang for the buck? So if you're getting more than $1, say if for every dollar you put into the project you're getting $1.10, then you're going to have a nice number bigger than 1. If you're getting only say 75 cents on the dollar, you're going to have not such a great number like 0.75, which means you're only getting 75 cents for every dollar you put in. And of course, that could mean people aren't working as hard as they could be, but it probably means that the cost estimators were overzealous in their in what they thought people could do. So, you might have to factor that in going forward. And then, of course, the schedule performance index is the earned value against the plan over the plan value. And so this is, again, what bang for your buck you're getting for progress. So basically for every, depending on how you're denominated, I was talking the last one in dollars. It doesn't have to be dollars, it can be euros or something. But anyway, this is, so depending on how you denominate your tasks, say for every hour you put into the project, how many hours of effort are you getting out? So again, a nice number bigger than 1 means for every hour somebody puts in, they're getting, an hour and a half, say, worth of effort. So your number would be 1.5. If, however, for every hour somebody puts in, if we're talking about our asphalt paving rate, you're only getting 75% of the way done, you're going to get a 0.75 schedule performance index. And so that's going forward, that's no good. Or not no good, but it's not great. Now, if you look at these top 4 equations, the cost ones are all, well, first they always start with the earned value. And so the cost ones always end with the cost numbers. So cost variance, subtracts the AC, cost performance divides by the AC. And then the schedule ones end with the plan value. So, trying to give you some hints and tips for coming up with these, organically, as you will. But hopefully in an easy way that you can brain them pretty straightforwardly. And you notice the variances are subtractions and the indices are divisions. So if you think about that hard enough and long enough, you can sort of derive those in your head by thinking earned value is always first and cost is second in the cost ones, plan value is second in the schedule ones, and then the variances are subtraction and the divisions are indices. So just something to think about. Okay, now there are various different ways to come up with the estimate at complete. And so based on the data that you're given, which is another reason to read the answers before you read the question, will help you determine, and also what data the question provides, which equation you're going to use to compute the estimate at complete. So one way is the budget at complete over the cost performance index. So that means, and remember, your cost performance index is bang for your buck. So if you budgeted out the whole thing and say it was $1 million, but your cost performance index says you're only getting, and I'm just going to make this easy for math, you're only getting 0.5 cost performance index,
yes,
then your $1 million is really going to be $2 million. And of course, obviously, you've performed some of the projects, so there's some more more complexity we're going to add to the equation. But so you can kind of see how that equation is rationalized. So part of it might be if you've got your budget. So the second way to come up with estimate of complete. So the first equation assumes that your cost was optimistic or pessimistic. So that's going to fix the cost, figuring that whatever cost problems you've had in the past are going to continue forward. So whether that's weather has hindered you at every turn, or government regulation has hindered you at every turn, or optimistic or pessimistic estimates have hindered or helped you at every turn, that's what the first equation is talking about. The second equation is just the straightforward, whatever problems or issues you had were just those one-time, say, weather issues, or one-time the city inspector didn't come out kind of issues. And the schedule and budget estimates are good, so there should be no trouble with that. So then basically you take the budget at complete minus the earned value. So that's what you plan to do, budget at complete, minus what you've done, and then you add the costs that you've already incurred. Okay, so you've got the whole sphere of work minus what you've done. So that's what's left. So the cost of that plus the cost you've spent. Then in the third equation, and it's probably easier if you write this out, because it looks a little bit funny like this across two lines, because it, I mean, it's a two-line thing, but the two lines are funny. So basically in the third equation, you assume that both the cost and the schedule estimates are going to be perverted by whatever problems you've had or however bad the estimates were, and that will continue on into the future. So here you're dividing by both CPI and SPI, because whatever bang you're getting for your buck for the cost and whatever bang you're getting for your buck for the schedule are going to continue on in the future. Now, the good news is, if those are both numbers bigger than 1, we were looking at the EAC calculation. So remember, the first one just assumes that the cost projections are bad. The second one assumes that neither schedule nor cost was bad, and that any upsets that you had were just temporary one-time things, but does factor them into account. The third one takes into account both cost and schedule as potentially being faulty, or that the problems, or maybe if the team that you have isn't a very skilled team because you had to hire a whole bunch of new people, that for whatever reason those problems will persist throughout the remainder of the project. So and then the fourth way to calculate that is just what you've spent so far and then your estimate to complete. And as estimate to complete is just what your estimate at complete is minus the actual costs. Now, of course, that again factors no issue with mitigating problems, and nor does it account for potential issues that you've had in the past. That it just says you're going to complete the project, and hopefully all your cost and schedule analyses will hold. And then your variance at complete is the budget at complete minus the estimate at complete. So again, negative is bad and positive is good. And then we have the to complete performance index, and that is the sorry, my phone's bugging me. Okay, the to complete performance index, TCPI, and now that's hidden under that little box that I want.
Oh, you see that?
Oh yeah, do you see that? Because I was gonna say, yeah, I don't want to see that anymore.
Oh.
There. Okay, now it's
there
on
it is.
somewhere else. Okay.
Funny that you could see all of that.
Yeah, so the to complete performance index, basically two ways to calculate. One is the budget at complete minus the earned value divided by the budget at complete minus the actual cost. So again, that says you're just managing to a budget and you assume that all the costs are good. And then the second way is budget at complete minus earned value, so those are the same, divided by estimate at complete minus actual cost. And of course, estimate at complete could be calculated any of a number, the number being 4 different ways. And let me say, because this is kind of a weird little subtlety, that you notice that the estimate at complete never solely has schedule performance index in the denominator. And so the first one has obviously just cost, and the third one has cost and schedule. And that's because you can always you can always buy schedule, you can make up schedule with cost, throwing more money at it or taking some of the scope away, what have you. But once money's spent, there's no way you can create money. So that's why schedule doesn't have to be in the denominator by itself, because you can try to remedy that. But cost is, once the money's gone, it's just gone. So now we're going to try a business scenario problem statement. So I'll let you read that and try to come up with what you think the solution is.
Okay. Okay, at the 30% mark, well, that's, first of all, I know that they're going to be over budget. They have a budget of 850,000, and they're not even at 50%, so they are going to be over budget.
Right.
I'm just trying to think. Would I do, now are you looking for me to use one of these formulas that we discussed?
Well, you could, you know, for instance, you've got the total budget of $850,000. So, and you've got an earned value of 255,000. So, and the project is 30% complete. So,
I mean, I could do the EAC minus the AC, you know, but I mean, I don't think it, I mean, if I wanted to put it on paper, I could do that, but we could see that we're going to be over budget if we're only at 30% of work completed on the project.
Right, and so for instance, if we looked at, say, the earned value of 255,000 over the actual cost of 310,000, you know that's going to be a number less than 1. So that means for every dollar you're spending, that's what, like, you're getting about 80 cents. So you're only being 80% productive with your money. So that, you know, that's already a problem.
Yeah. They're not using any formulas here, you know, in the company, which is a problem. But I mean, looking at this, you know, somebody told me I had a budget of 850,000. I said the 30% mark. We're already at 310,000. I would start looking at what else, you know, what are the resources involved? You know, is it possible that I could finish the rest of the work based on whatever is left? Because maybe I could. It depends on whether it's labor or if I have to buy a certain particular item to get the job done. But I could definitely tell from this that you're going to be over budget if you're only at the 30% mark.
Exactly. So those are the kinds of things, if we look at the solution that's offered, these are the kind of things that, you know, that the solution looks at. So obviously you haven't been successful with either with your cost estimates or with your cost productivity. And so, but like you said, you know, going forward now, do I have the easy stuff left? You know, we were talking about the problems with software, and maybe all the problem software is done and easier software, or because we've done this other software, now we finally figured out how to do it. You know, maybe we can, going forward, do it a little bit better. So, and it mentions here that the project has faced some unexpected events, which kind of known as unknown unknowns, and that is where you want to put your management reserve money for such occurrences as the unknown unknowns. And then you have some known unknowns, you know, for instance, weather is always, say, in the construction business, always a possibility. So when, you know, you've got to factor a little bit in for that. So that would be a known unknown, and that would be your contingency reserve. So basically, that's what kinds of things you want to look at when you've got these calculations going on. Okay, now. Okay,
tell you really quick. This is, I don't know if you know that 310,000. We put 310, you know, K or 850K. Do you know that the bank does not do that? Because I got a price, and 1,000 is M and million is MM. I said, where did that come from? I didn't grow up like that. But when I got my quote, and I said, this is not right. And so they go, oh, no, it's right. I said, no, because the thousands is represented by a K. And they said, no, it's an M, and million is MM. Did you ever hear of that?
I have not ever heard of that. That's very interesting. Are they a foreign company?
No. Well, we are, you know, but not the bank. It's PNC Bank.
Wow, that is very interesting, because no, I hadn't heard that before.
I told them it was an error when I saw it. I said, that's a mistake. And No, you know, million is MM and thousands is just an M.
Because, yeah, that was the only thing I was thinking, that maybe it could be a foreign thing, because, you know, they are confused about what's a, you know, what's a dot and what's a comma. But yeah, I know we use those differently, but that's interesting that they would use the letters differently.
Yep, they're used different.
Huh. That could be very problematic.
Yeah, I'm glad it's not just me. I want to see if you knew that.
No, haven't seen that before.